Hello, this is Dr. Armand again. Today we'll be looking at how to effectively draw and search compounds on the Webcsd that pertain to the Experiment 8 post-lab questions. So sit back, relax, and enjoy the show. So I've brought up the Webcsd page. And for one of the compounds you may search, caffeine, the most effective way to look it up is to do a simple search. So this is for caffeine. And the reason a simple search is preferred is because if you do a substructure search, you get a lot of hits. So what we're going to do is do what's called a simple search, and we're going to type in the compound's name, caffeine. Make sure you spell caffeine right, or else you may not get any searches, any hits. So we click on search, and it's going to search the database for anything that has the name caffeine in it. And so when you do a simple search, the unique thing about it is that it puts the ref code and the structures diagram next to it. So you can quickly search through and find any structures that just contain caffeine. So for example, here you may say, oh, CAFFCD, maybe that's one of the structures. But the answer is no, because it doesn't just have caffeine, it has H2O as well. So you're only looking for the structures with just caffeine. Now, just for example, I've had a lot of questions about this. Some of the questions ask for the space group. So if you're given a space group that has a subscript, say P21 upon C, you would just write it as P21/C. You don't have to use any subscripts when writing the space group. So you would scroll down, you can quickly look and find which structures have just caffeine. Again, this one, CA-fine, is not one because it contains water in it. So you click next. And then quickly scroll through and look for the structures that only contain caffeine. And this is the most effective way of looking up to find the structures that just contain caffeine. So next we're going to go to structure search, and the next structure we're going to search for is caffeine and salicylic acid. And so we're going to be using the structure search to do this. And so make sure you draw it exactly as I draw it. And we're going to be doing an exact search. So down here, you make sure you have exact specified. And so for the caffeine, you're going to need a 6-membered ring, a 5-membered ring, and then we got to add some nitrogen atoms on it. So nitrogens go here, here, and there. Next, we need to add some carbon groups. So for example, if you have the bond selected and then select carbon, when you click and drag, it adds a CH3 group. So we're going to add a CH3 group there, there, there. And we're going to put one here for now. And here, we're going to change these to double bonds. And then we're going to select oxygen. Right there. We're almost done with caffeine. Now we're going to place double bonds. Oops, not that. That's no good. Double bond here and here. And that's what caffeine should look like. Now we're going to draw salicylic acid. So again, we're going to select the phenol ring, bring it here, then move this to single bond, select carbon, put a carbon there, there, and make this double bond, and then put a carbon here. Now we're going to change these to oxygens. So don't worry that this has an OH. We'll fix that. So what you do is you click on the eraser. Now select double bond. Do that. So now when you click oxygen, it just puts an oxygen atom. Now we want to remove the hydrogen off this OH group. Let's click erase. Click single bond and just click it. Now click the oxygen and it has that. The rest of the positions we're going to put hydrogen. So we need to select hydrogen for that. So on the left is caffeine, on the right is salicylic acid. And we're going to do an exact search. Now we search and we get 2 hits. Well, hopefully these 2 are the hits you need, and they are. So you'll need to scroll through each hit and find out the questions, the answers that you need for the questions. And so, for example, the deposition numbers and additional details. Associated publications contain the journal and the year. For example, this is 2008. If you scroll down, here you have the space group P21 upon N. So if you were to answer this space group, you would just say P21/N. That's it. Nothing else. No subscripts in the answer. And so this is how you look up salicylic acid and caffeine. Now let's go back to structure search. The next compound I'm going to show you how to look up is para-aminophenol, which is actually the precursor to making acetaminophen. So here we're just going to click on clear structure. Now for para-aminophenol, we're going to select the phenyl ring. Then make sure this is, then select single bond, select carbon, and we're going to get that. Now select nitrogen and click on the CH3. Now see how it changes it to NH2. That's what we want. Then click oxygen and click that here. It changes to OH. Now we want to add hydrogen atoms on the rest of them. So we just select hydrogen and draw the bonds. So this is para-aminophenol. So now we're ready to begin our search. And so para-aminophenol comes up with 3 hits. One of these 3 hits, or in these 3 hits, you should see the structures of just para-aminophenol. Now if I just click on one of them, for example, obviously this one's not para-aminophenol because it doesn't just contain the 2. But if I scroll down, again, deposition numbers and additional details. Associated publications contain the authors, the journal, the year, and then the space group. So for this space group, if you were to get it, P1 with a bar on top, you would just answer it as P-1. And that's how you would answer for that space group if you had it. So that's how you search for an exact search of para-aminophenol. Go back to modify search. Now we're going to look for a protonated para-aminophenol. So protonated para-aminophenol. And the way we make it protonated is we're going to first erase the nitrogen. We're going to click on nitrogen, click and drag. So we have this. Now select hydrogen. we're going to add 3 hydrogens to the nitrogen. That's how you protonate an amine. It has 4 bonds, 3 of them hydrogen, 1 of them an R group. So now we're going to go down and scroll for a protonated version of a para-aminophenol. And actually you're looking for this structure with a particular anion. And in the question they'll tell you which anion you're looking for with it. And it's just that anion and the structure. So for example here, if we were looking for perchlorate, for example, this one wouldn't be a structure because in addition to the para-aminophenol cation and anion, you have water. So this one would not work. So you need to scroll through the, I believe it's 13 hits, and see which one just contains the protonated version of para-aminophenol and the anion that was in your question. So now we're going to go back to modify search. And in this case, we're going to look up one of the medicinal compounds that was used before acetaminophen, phenacetin, and we're going to do an exact search on phenacetin. So what I'm going to do here, just to clean this up, I'm going to delete the nitrogen and the hydrogens there and this O here. I'm going to go select carbon. I'm going to change this to a nitrogen now. Go back to carbon. Select oxygen. Now it gives me that OH. Delete that. Select double bond. Now select the O. Bada bing. Now down here, we're going to add the ether group. So we add the oxygen. And we select carbon. Like that. And that is phenacetin. Now we're ready to begin our exact search of phenacetin. So make sure you have exact picked, hit search, and then you would scroll through and look for all the different compounds or for the structures that only contain phenacetin. So you would scroll through, click on each one. Here there's only 11 hits, so it won't take too long to find this. And that is how you do an exact search for phenacetin. Now we go back to modify search. We go to clear structure. Click on the sheet. Well, I didn't need to clear it, I guess, but so now we're going to look up acetaminophen. So we're going to draw the phenol ring, select carbon, click, change that to a nitrogen, good, back to carbon. Now what we're going to do is select double bond, just bring it here and click, and then put the O. Now for acetaminophen on the other side is an OH. Let's undo that. Let's select carbon. Now let's select oxygen, and we have our OH. The rest of the positions are hydrogen atoms. And so acetaminophen would look like this. Now we're ready to do our exact search. Scroll down, hit search. And so acetaminophen, you have, I mean, this is the only one where you have more than like say 20, 30 structures. You have 106 results. So you have to go through, you click on each one and find out which ones only contain acetaminophen. Only acetaminophen, nothing else in the structure. This one's a pretty cool structure because it's actually co-crystallized with two drugs. We have ibuprofen and acetaminophen. And sometimes researchers do this to see if they can enhance the medicinal properties by combining two drugs. So what this research group was able to do was to crystallize ibuprofen with acetaminophen. So you would go through, scroll, find out which ones only contain acetaminophen, and then answer the questions for acetaminophen. Now let's go back to modify search. And again, acetaminophen is a weak base, FYI. Now, so medicines usually are weak bases or weak acids. Acetaminophen is a weak base. Weak acid are things like aspirin, ibuprofen, naproxen. And so now we're going to look up naproxen, which is the trademark name is Aleve. And so for naproxen, we're going to need the phenyl ring. We put two of those together like this. Then we're going to add an ether group. Change this to O like that. And now we're going to add the carboxylic group. So it should look like this, and then we're going to add, of course, the hydrogen atoms. So this is naproxen. Should look like this. Oops. There we go. Now we do an exact search. Search. And so again, there's only 47 results. You just go through and find the ones that just contain naproxen in it. And as you see here, I just clicked on this one, but this research group crystallized naproxen with an amino acid, proline. And again, researchers do this to see the interactions of how these drugs interact with, say, amino acids. On a side note, it was just published in the San Antonio News that some of the chemistry professors at UTSA are working on trying to find a treatment or a way to treat the coronavirus. And so they have different compounds they're looking at to see if any of these can help treat the coronavirus. And if you get a chance, you should read over that article in the San Antonio News. I think it was just out a few days ago. And so this is how you look up naproxen. And then lastly, we want to look up ibuprofen. So we're going to go to clear structure, select the phenyl ring, select single bond, select carbon, like that. And on this side, we're going to put the carboxylic acid, like that. Select double bond. Select oxygen. Now we're going to add the hydrogens. And hit do an exact search. And so here we found 45 results. So you would scroll through, see which ones only contain ibuprofen by itself. So you just click on one. This one wouldn't be one because it's crystallized with something else. So you're only looking for ibuprofen. And so that concludes today's tutorial on looking up those compounds you may encounter in the Experiment 8 post-lab questions. If you liked the video or learned something new, make sure to click the like button. And until next time, it's Dr. Armand signing off.